Welcome to the robotics class for February the 4th. As I said right before I turned on the recording, we're going to be talking about a bunch of stuff today that you might possibly have a little trouble understanding the first time through, and so you might appreciate having a recording of it up on Canvas. So let's do that. And let's see, first, before we talk about the robotic stuff, let me go over a couple important announcements. One is that hopefully you guys now have already been told by your teachers from your other classes the next week is going to be a kind of a weird week. We are, whoops, why is it sharing? It shouldn't be sharing right now. Sorry, I didn't intend to share that. Not that it really matters, but okay. So next week, on Monday, Tuesday, and Wednesday, all of the teachers at Ames are going to be off at a conference. It's an online conference, but we're not going to be able to teach live Monday, Tuesday, Wednesday. And so we are going to have other activities there for you to do. Hang on a sec. Somebody just got here. Let me let her in and mark her tardy. Okay. All right, so as I was saying, Monday, Tuesday, Wednesday of next week, I won't be here to teach you live. So what I'm going to do instead is I'm going to post stuff on Canvas. And so I haven't fully figured out what I'm going to do, but what I'm thinking is if necessary, I'll record a little video so I can give you instructions via video. Or if I think it's not necessary, what I'll do is I'll just post an assignment. And so just go on Canvas and look on Canvas and it should be clear. So Monday and Wednesday, I believe, of next week is when we're going to be meeting, or at least when we would be meeting normally. So that means both on Monday and on Wednesday, just look on Canvas, you'll see an assignment. I'll try to post a little bit early. So if you want to work the assignment a day or two ahead, hopefully you'll be able to do that. But I can't guarantee I'll do that. But certainly by the day, I will have something up there. Okay, so let's see. So your assignment last time was just get the IDE loaded onto your computer and verify that you can create a program in Tinkercad and then download that program from Tinkercad into your computer and then upload that program from your computer into the Arduino. And I didn't really care what program you used. I gave you a sample program of mine. And so what the sample program did that I gave you was that the program just ramped up and ramped down the motor. So the motor started out spinning slowly. And then as time went on, it got faster, faster, faster. And then it stayed at full speed for a while. And then it ramped down and then back up. So that was just a simple program that I just put together. But you were able to do that for any program that you wanted. And most of you were able to successfully do that before the class period ended last time. But a couple of you had not yet done that. So what I'd like right now is just everybody, please type in the chat box, type it in a private message so that nobody else can see. And I want you to say yes if you successfully did everything that I just described. So first step, create a program in Tinkercad. Second step, download it from Tinkercad to your computer. And then the third step is upload it from your computer to the real Arduino and verify that it works. Okay, so everybody's type yes if you did that. And most of you did it before the class was over last time. So, but go ahead and just type in yes. And if the answer was no, then let me know no. Okay. All right, good. So I see that the one or two of you that had a little bit of trouble last time, you have now solved that problem. Okay, so that's reassuring. Have I got yeses from everybody here? Oh, okay, so Trey. Yeah, I remember. So you didn't have the Arduino yet. Yes. So if you, in your note here, you said that you'll go in this weekend. Well, I trust you realize that school is not open on weekends. So what you mean is tomorrow, right? So Friday, which is tomorrow, go into the school and pick up the kit parts from the school. Now, speaking of tomorrow, I trust that you guys realize that every Friday is a work day for the robotics club. Now, you are in the robotics class, which is a different entity than the robotics club, but every one of you is invited and encouraged to join the robotics club. Now, I don't require it. If you choose not to join the club, I will still like you and I will not hurt your grade any, but I do encourage you to join the club. And so every Friday from 10 o'clock until 4 o'clock, roughly, that's when we're going to be working on the big robot. So what you guys are doing right now, you're working with little baby things. You know, got these little baby motors and these little Arduinos that run them, and they're so cute, right? But the real robot uses big motors, and it's a big robot. It's it's over 100 pounds. I mean, this is a very big, very powerful robot, and it isn't run by an Arduino. It is run by a thing called a Robo-Rio, which is, think of it like an Arduino on steroids. So if you can learn how to program an Arduino, which is what you will learn in this class, once you know how to do an Arduino, it's not that much more difficult to do a Robo-Rio. I mean, there are some complexities that you do need to learn, but much of it transfers over. So if you can program an Arduino, you should be able to program a Robo-Rio fine. So I would hope that you guys could come by tomorrow. So I'd like you to type in the chat box again. Type in a yes if you think that you are able to come tomorrow at some point. You don't have to be there right at 10, and you don't have to stay all the way till 4. If you can just come in at some point tomorrow, type in yes. And if no, then that's okay. I'll still like you. Okay, so I see one of you says that you can be there, but not until noon, and that's okay. Others of you are saying yes. Some of you are saying, I think so. All right, good. Okay. All right, so we have a lot of work to do on the big robot. And so I would appreciate any help that we can get. Now, what I need to do is I don't want to spread coronavirus. And so I'm going to do the same thing that I did last time. When you first arrive, I'm going to take your temperature to make sure that you don't have a fever. If you have a fever, I'm going to send you home. And then I want to do that rapid COVID test that some of you did, but maybe others of you didn't. You know, we take a Q-tip and we get a little bit of mucus from your nose, and we put it on a special test kit, and within 15 minutes, it'll tell us yes or no whether you have coronavirus. Now, it's not 100% yes. There have been a lot of false positives and false negatives. I don't know about the false positives, but I know there's been some false negatives. So it doesn't guarantee that you don't have coronavirus, but it is a good indication. Now, Mr. Wilson wants to have parent permission. So what I'm going to do is, let me make a note to myself. What I will do is today, after class lets out, I will send an email to everybody's home asking for your parents to please respond to give us permission to do a coronavirus test. If your parent chooses not to give permission to do the coronavirus test, then again, I will not think badly of you or your parent. I understand people, may not want to do that, but I can't let you into the room if you don't pass the test, because I don't want any chance that we spread coronavirus to each other. I would be devastated if you picked up coronavirus at school and took it home to one of your family members. Now, what I'm hearing is that young people don't usually get very sick and don't usually die, although it does happen. But what does happen is that young people give the virus to their parents and grandparents, and then their parents and grandparents die. And I would be absolutely destroyed if I knew that that happened to one of you. And so the rule is, if your parent says that they don't want you to be coronavirus tested, then I can't let you into the room tomorrow. Okay, so make sure you understand that. Okay. So I think we're good. Now, let's talk about the latest homework assignment. I gave you guys an assignment. I'm not talking about the one that was due today. I'm talking about the one that was due last time that we didn't really take the time to talk about last time. You guys, so I gave you guys an assignment to create something in Tinkercad, and it was very interesting to see what you guys did. People took a different approach to solving the problem, which is something I love. You know, I really like it when people use their creativity, come up with different solutions to the problem. So let me share my screen here. Okay, so well, first off, I need to explain something that apparently I didn't do a good enough job of explaining last time. So remember the oscilloscope, and we were using the oscilloscope to keep track of the what we called the pulse width modulation. In fact, you know what? I think rather than just looking at a static image, I think it would be better. Let's actually open up a real file. That's a better way to do it. So let me go into Tinkercad and wait while it opens up. You know what I've discovered is when I use Tinkercad in the evening, it opens up pretty quickly. But when I use it during the day, it's really slow. So I'm guessing it's because there's people in school classrooms or whatever who are, everybody's using Tinkercad during the day, and so it runs more slowly. In the evening, it seems to run pretty quickly. All right, so yeah, let's pick up this one. This one is actually what your homework is going to be tonight. So it's a good example to use to play with. Okay, so what I'm going to give you as a homework assignment tonight is I want you to hook up. Let me stop the sharing while we're waiting here. Okay, I'm going to have you guys take one of these devices here. This is called a potentiometer. Basically, it's a knob. Okay, you turn the knob. When you look in your kit of parts, you will find that you have one of these. You might even have two. Now, it may look a little different because, okay, this plastic knob, it just slides right on and off. So if yours doesn't have the plastic knob on it, don't worry, it still works. But I'm pretty sure I gave everybody a plastic knob too. So hopefully yours looks like this, right? And so this is a variable resistor. In fact, it has a special name. It's called a potentiometer. But just think of it, it's a resistor where by changing the knob, you can change what the resistance is. So your homework assignment tonight is going to be to hook up an Arduino to one of these little baby motors. Okay. But you're also going to hook up a potentiometer in such a way so that when you turn the knob on the potentiometer, the motor speeds up. And when you turn the knob the other way, the motor speeds down. So the Arduino is going to be looking at the potentiometer to see where have you got the potentiometer set. And based on that, the Arduino will then set the motor to run at the appropriate speed, either full speed or half speed or quarter speed or what. Okay, so my Tinkercad should be up and running by now. Let's see if it is. Okay, good. It's up and running. Okay, so this is what it's going to look like. So, okay, so you can see I've got the knob right here. Let me move a couple windows. I got a couple windows on my screen that you guys can't see, but they're kind of in my way here. So, all right. So this is the knob that I was talking about right here. This is the potentiometer. And it's got 3 leads on it. And so we're going to feed the potentiometer into the Arduino. And I don't want to take the time right this minute to talk about it, but later today, before we leave, I'll talk about where to plug it in and why we plug it into those places. Okay, and so this will be the input to the Arduino. And then based on what we've got it set at, the Arduino will then run the motor at different speeds. And now the reason that I came in here today was, or just now, is because I wanted to talk about the oscilloscope. There's something about it that I maybe didn't make plain before, is that if the oscilloscope is set right, then you'll be able to see the pulse widths wonderfully. Okay, so I just started the simulation. Okay, and so you can see that our pulse right now, and let me turn on the annotation. Okay, so you can see that I'm getting full voltage for approximately 1/5 of the time. And then I'm getting 0 voltage for approximately 4/5 of the time. And then I get another pulse and then another pulse and another pulse. And so the way that the Arduino controls the motor, and by the way, this is true for all motors. All motors work this way. If you want the motor to run faster or slower, you control it by this technique, which is called pulse width modulation. So watch what happens when I turn the knob. You see how the pulse widths get fatter. If I take it all the way up here, okay, so now it goes to full on. So now this motor is running at full speed. And in fact, if you look down here at the RPMs, you'll see it's 5,555, which is basically full speed for a motor that's running at 5 volts. Okay, so then if I come down here, come on, there we go. Okay, so I'm turning the knob down and you see the pulse width is changing. Okay, now you can only see this happen if the oscilloscope is set for the correct setting. So this number that you see right here, time per division, and in fact, let me do that again. Okay. So time per division is 1 millisecond. So what that means is the oscilloscope is basically taking a picture of the voltage, and it's a super high speed picture. So every square corresponds to 1 millisecond. So when we see the pulse go up, and then it's on for a little while, and then it's off, and then it comes up again, and then it's off for a little while, and then it's okay. So you'll notice, in fact, rather than looking at pretend pulses, let's go back. Let's look at a real pulse. So let me start the thing going. Okay. And now let me turn annotation back on again. Okay. So you can see here that this pulse came on, and it was on for a little bit more than 1 square. And then it went off, and then it came back on again. And so the time delay between when one pulse came on and when the next pulse came on, that time delay is equal to 2 squares here. Each square is 1 millisecond. So what that means is every 2 milliseconds, I'm getting a pulse. And I can control what the width of that pulse is by changing my setting here. Now, when we did this before, we didn't have the potentiometer. We just had it work, based on push buttons or whatever. Okay, but now we're going to do it based on a potentiometer. Okay, so right now we're getting, it's on for approximately 1/5 of the time and off for approximately 1/5. So it's basically on for approximately 20% of the time. So we call that a 20% duty cycle. Okay, but we can only see what's happening if our time per division is set properly. And the correct setting that we want is we want 1 millisecond per division. That is not the default setting. When you pull in an oscilloscope, when you come over here to to the things on the right, you pull in an oscilloscope, the default setting is not this. I think the default setting is 100 milliseconds. I'm thinking that's what the default setting is. Notice we're getting just a bunch of gibberish over here. See, we can't very well, and also this happens a lot where you get these really weird things happening like that. Okay, if the time per division is not set right, you're not going to be able to see what's happening. And in fact, you know that it doesn't have to be in milliseconds here. We have the option, we can set it for microseconds and nanoseconds, and we can actually even set it for seconds if we want. And so if we set it for the wrong thing, what we're going to get is just total gibberish. Okay. So let me suggest that everything that we're going to do, I think for this whole class here, now my Tinkercad is locked up. Okay. All right. So for this class, I would recommend let's always use milliseconds, and let's always set it for 1 per millisecond. And so if we use those settings, then we'll get results where we can actually see what's happening. Okay, so the motor runs more slowly, motor runs faster. Okay, so that's a preview of what we're going to do for tonight. But before we talk some more about tonight's homework assignment, I want to talk about last time's homework assignment, because like I started to say at the beginning, and then I kind of got sidetracked, you guys came up with some interesting solutions that I think are worth sharing with everybody else. Okay, so this was Scott's solution. Now, this is just a screenshot here. I don't have the actual thing working. I just took a quick screenshot of it. Hey, Scott, you know that I like you, right? Can you unmute yourself and say yes? Okay, good. So please don't feel bad if I critique what you've done here. It's not because I don't like you. But what I'd like you to do is I'd like to compare this thing that Scott did with this thing that Trey did. There's some important differences. Now, both of them worked fine. Scott's solution and Trey's solution both worked fine. But I like the way that Trey did it rather than the way that Scott did it, because Trey's solution, it's all laid out nice and neat, so that if for some reason it wasn't working right, I could look at it and I could figure out what's going on. Okay, I can see that, you know, this switch right here, it gets its power from there, and then here's the resistor and it goes off to ground, and here's the resistor that goes off to the A1, and this guy here works the same way. Everything is laid out nice and neat, so it's easy for me to see what's going on. And believe me, guys, when you make some of the more complicated stuff that we're going to do later, if you don't lay everything out nicely and neatly like this, and then you go to run it and you find out that it doesn't work, you're going to have a devil of a time figuring out what's going on. So Scott's method is not horrible, but it is a little bit harder to figure out what's going on. You know, we've got this jumble of wires here, and yeah, I guess, I mean, I could sort of figure it out. You know, if I take this blue wire here and I trace it down, okay, yeah, I can figure it out. So Scott's solution is not horrible by any means, but you know, the way it's laid out with this zigzag thing, it just makes it a little bit harder to figure out what's going on. Whereas Trey's is just a little bit easier to figure out what's going on. So let me suggest that you always do that. Okay. Now there's another thing that I insist on, and I was very glad to see that you guys were really good about doing. The color of the wires is very important. When you guys work on a robot for the robotics club, for the first robotics organization, they are very, very, very strict about wire colors. If your wire colors are the wrong colors, they will not let your robot onto the field. So this pin that you see right here, let me switch to a different fatter pin. Okay, so that pin right there, the one that says 5V, okay, that pin always has 5 volts on it, regardless. I mean, there's no way that you could not have 5 volts on there. No matter what you program into the Arduino, it's always going to be 5 volts on there. So any wire that's connected to that pin is always going to be at 5 volts. And so any wire that you know is always going to be at your supply voltage, that wire needs to be red. And I was glad to see that pretty much all of you did that. Okay, so this wire here is always 5 volts, so it's red. Now the way switches work, the left sides, those guys are always connected. Even if you don't push the button, those guys are still always connected. So that means that this wire is always going to have 5 volts on it. And this wire here is always going to have 5 volts. So all of these wires that you see here that Trey has made red, he's done it exactly right, because even if you don't push the button, there will always be 5 volts on those red wires. Now the blue wires, okay, they're a different story, because these guys, in fact, tell you what, let me switch from red to blue on my color here. Okay, so these guys right here, well, they might have 5 volts on them, but then again, they might not. It depends on whether or not we've got these buttons pushed. Okay, so if you have a wire that maybe is 5 volts, but maybe not, well, don't make it red. Make it be some other color. And I was glad to see that pretty much all of you guys did that. Okay, and then what about a wire that you know is always going to have 0 volts on it? Well, yep, we've got some of those, because all of these black wires that you see right here, they all go into this common ground. So anything that's plugged into this pin that says labeled GND, that will always have 0 volts on it. And so the rules are, any wire that you know is always going to have 0 volts on it needs to be black. Okay, so you guys were really good about doing that. So thank you for that. All right, let's see a couple other things here. All right, Zane, you know I like you, right? Can you unmute yourself and say yes?
Yes.
Okay, good. All right. So again, if I critique your drawing, it's not because I don't like you. So let me just ask here, Zane, I didn't understand what this guy is here for. What purpose is he serving?
Originally I was going to power the motor and the buttons off of it, as well as the Arduino, but for some reason I couldn't get a transistor working. I don't know why, so I just went with the simple design.
Okay. All right. Okay, good. All right. Yeah. So I can see what Zane was doing. Zane always likes to be 1 or 2 steps ahead of the rest of us. And by the way, I heartily encourage that. So what Zane wanted to do was he wanted to set it up so that we could run a motor not directly from the Arduino, but we could run a bigger motor, like maybe a 12-volt motor or something like that. And so Zane correctly recognizes that if we want to run any motor that's not this little baby motor, we cannot power it directly from the Arduino because we'll destroy the Arduino. And so Zane was playing around with this power supply in anticipation of something that I am going to have you guys do later, just not today. But at some point in the not too distant future, we're going to learn how to take an Arduino. In fact, tell you what, let me turn off sharing so that you guys can see. Okay, so super important rule that I'm going to say many times. The only motor that you can power directly from the Arduino. In fact, let me get an Arduino in my hand. Okay. Okay. The only motor that you can safely power directly from the Arduino is this guy right here, the little baby motor. Now, in your kit of parts, you've got another motor right here that might look like the baby motor, but you see it's different. Let me take the propeller off the baby motor here. Okay, so this is the baby motor. This is the motor that's not quite a baby. I mean, it's a tiny motor. Maybe let's call this a toddler. Okay, so this is the baby and this is the toddler. The baby motor, you can safely power that directly from the Arduino. The toddler motor, you might damage the Arduino. In fact, let's say you will damage the Arduino. If you try to run this guy directly from the Arduino, you will damage the Arduino. And then this guy right here, for sure, you're gonna destroy the Arduino if you try this guy. Okay, but even this guy, don't do it. Okay, but there are tricks that you can do. I mean, if you want to control this motor where the Arduino controls it and the Arduino determines how fast it's going, you can and will do that. The only thing is that the power for this guy has to come from another source. He can't come directly from the Arduino. Okay, so we talked about that last time. Remember the way we did it was we used relays and we used transistors. So we're going to talk more about that later. All right. So that's what Zane was doing, was he was trying to set up one of those, and then I guess he stopped partway through there. So okay, that's fine. Okay, this one was really good. So this was Eric. Many of you didn't quite know what to do because I asked you to send me 2 different links. When the homework assignment that I gave you that was due last time, I gave you 2 jobs that I wanted you to do. One was this job right here, which was called the autonomous job. And the other one was this one right here, which we called the teleop job. And so you had to send me 2 different links. And most of you guys, you really struggled with that because you didn't know if Canvas would accept 2 different links. So some of you found out that Canvas actually will accept 2 different links. The way you have to do it is you have to submit one link. And then after you've submitted that link, you have to come in and submit the second link separately. So most of you figure that out. Now, others of you, the way that you got around the problem was you submitted the one link in the text box, and then the other link, you put it in the comments box. That works great too. That was fine. Those of you that did it, you did great. Okay. Others of you emailed it to me. Okay. But Eric knew something that apparently the rest of you didn't know. Eric knew that it's actually possible to have 2 different Arduinos in the same Tinkercad file. And this is cool. And this is not something that's obvious. So tell you what, let me go ahead and click on this. And let's go directly to Eric's thing. Hang on a second here. Doesn't want to cooperate. Okay, so let me do it this way. I'm going to copy it here. And I'm going to go into here. Okay. All right, now while that's opening up, okay, so let me share my screen with you. Okay, and it's still opening up. It's a little bit slow. Must be a lot of people using Tinkercad right now. This seems to be the worst time of the day. Oops, why did it not like that? What's that message say? Page unresponsive. Yeah, let's try waiting. Okay, or not. Let's see, there's another way I can get into here. So let me go in this way. I'll go into, let's see, is that my physics or is that robotics? That's physics. Oh, that's okay. Let me go into here. How are we doing? Are we in yet? Nope, still not in yet. Okay, so be patient here. Let me go into the robotics link. I think maybe the whole internet is running slow. Not just Tinkercad, it's the whole internet. Okay, let me go into the modules. How are we doing? Still, nope, still nothing. Tell you what, I'm going to give up on that. Something's seriously wrong there. Let me go back to here. And okay, so this was the assignment. Whoops, where'd you go? Okay, so this was the assignment that you guys were supposed to turn in. And so let me click on here. And now, when you guys turn in assignments, this is the way that we teachers grade them. We go into this thing called the speed grader. So maybe I shouldn't be showing you this. These are the secrets of how things work. Okay, so I'm going to go into Eric's submission right here. And I'm going to click on right here. Okay, so hopefully it'll open up this time. Should I sing the song again? The do 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 do. No, I sang that last time. What's a different song we can sing while we're waiting? Sea shanties. You guys know that sea shanties are supposedly all the rage now. So let's sing a sea shanty while we're waiting here. Let's see. Anybody know any good sea shanties? I want. What do you do with a drunken student? What do you do with a drunken student? What do you do with a drunken student early in the morning?
I guess you're gonna suspend them.
Yeah. Yeah, your guess is right. Come on, Tinkercad, don't let me down here. Why are you so slow? Well, maybe we won't be talking about this. There must be too many people using Tinkercad. Okay, well, tell you what, let's go back to my PowerPoint. Okay. So I'll just have to tell you, and you guys have to use your imaginations here. Okay, it turns out that you can have two different Arduinos in the same Tinkercad file. Now it gets a little bit confusing because when you write the code for it, how do you know which code goes with which Tinkercad or which Arduino? And so this is the thing that I was hoping to show you live, but I guess I'm just going to have to tell you, and you're going to have to use your imagination. So here's the way that it works. Okay. If you click on one of the Arduinos, so let me open up my notation here. Okay. If you come in and you click on this Arduino, it opens up a little window and it says, you know, Arduino such and such, and it has like a number 1. And if you click on this guy, he would be Arduino number 2, right? So if you click on the Arduino, then while this little box is showing for that Arduino, then you know up in the top here where it says code, okay? So if you click on the code while this guy is highlighted, the code that you get will be the code for this guy. And so then you go ahead and you write the code for this guy and get it all working right, fine, okay? And then you say, okay, now I'm done with the guy on the left. Now I want to do the guy on the right. So how do I get the code for the guy on the right? Well, click on this guy and it will open up a little window and it'll say Arduino. And then as long as that's opening, then what you can do is you go up to the top again where it says code and you click on the code. And now the code that it shows you will be the code for this guy. Okay. And so if you do that, then you can actually have two Arduinos running at the same time, which, you know, might seem a little confusing, but it does work. Oh, hey, it looks like it's open finally. Yeah, okay, good. All right, we're up, we're running. All right, can you guys see my Tinkercad file now? Somebody say yes if you can.
Yeah.
Okay, good. All right, so let's see if I lied to you or not. Okay, let's suppose I want to see the code for the Arduino on the right. So I'm going to click on that. Come on. Okay, there it goes. Okay, so it opened up the little window. Now, for some reason, it called it component number 3. Okay, so while this is open, now I'm going to click on the code window. And so here we're seeing this is the code for the Arduino on the right. Pretty simple code, right? Okay, so notice what that looks like. So now I'm going to close that code up. And so now I'm going to click over here so it's not highlighted anymore. So now I want to see the code for the guy on the left. So I click on the guy on the left. And for some reason, it doesn't want to work. Come on, there it goes. Okay, so the little window opened up, but this time notice it's got a different number on it. Okay, so this now is the code for that guy. So now if I click on code, you'll see we got entirely different code than what we had before. We've got this really weird code, which for some reason he didn't tie all the code together. Normally what you want to do is you want to have one long string of code. You want to have this guy, whoops, I didn't want to do that. You want to take this guy here and you want to, oops, okay, this is a little tricky here. So maybe I shouldn't mess with his code here, but you want to tie them all together. But he likes to be different and I encourage different. So the bottom line here is the code that we're looking at right now is the code for the Arduino on the left. Okay. So by doing what he did here, Eric was able to get around the problem in a very different way from what the rest of you guys did. So congratulations, Eric. I was really glad to see that you did that. Let's see, did I have any other examples that I wanted to talk about? No, I think that was it. Okay. All right, so let's talk about tonight's homework. Let me share my screen again. Okay, so I'm gonna come in here. All right, so let's go into this one here. So if we go to the modules, you guys are going to see that I have given you 2 homework assignments. One of them is due next time we meet. The other one is due this coming Saturday night. And the reason I think I can get away with that is because you guys have got tomorrow. You know, so many students think that Friday is a day off. If you think that, you are wrong. Friday is not a day off. Friday is a work day. You just don't have live teacher interaction. Okay, so I have given you an assignment right here, and notice it's due on February the 6th, which is this coming Saturday at midnight. I've got this assignment here. It says, I want you to download and read something that I have called the Arduino Primer. So if I click on this, you'll see that I've got a link here, and this link will take you to a document that is called the Arduino Primer, which is basically an Arduino user's guide, but it's in comic book format. If you click on this, it'll download the file to your computer, which is what I recommend you do. But if you prefer, you can click on the icon here, and it'll open it up right here in Canvas. And it takes a little while to fully open up, almost as bad as Tinkercad. There we go. So you see, it's a little comic book thing about Arduinos, and talks about how to use Arduinos, talks about how to hook them up. And this thing right here, this is called a breadboard. In fact, let me zoom up a little bit to make it a little easier. This thing that you see right here is called a breadboard. If you look in your kit of parts, you'll see that I have included a breadboard. I just haven't talked about it yet. So this talks a little bit about breadboards. Here we've got some on-off switches. Here we got a motor, some more switches. Talks a little about what is voltage, what is current, what is resistance. Great stuff. You guys really, really need to read this. I've used these terms a lot, but you know, it's probably a good idea if you go back and read it to make sure, okay, that you understand how it works. Some great thing about how electricity works. Here's where you can get the Arduino IDE, which you guys now already have. Okay. Here it talks about how to get some examples. Okay. Okay. This is the good part right here. All of the programming that we've been doing in this class, we have been cheating. We have been letting Tinkercad do the hard work for us. Let's come back to, okay, let's do this one. Okay, so when we have programmed this, Tinkercad has really done all of the programming for us. And so we've been using these drag and drop blocks. This is not really the code. If you want to see the real code, you have to come down to this thing where it says blocks plus text. This is the real code. And this is something that I have not talked about, because this is something that Mr. Webster teaches. And so if you really want to understand how to do real code, I would recommend that you take Mr. Webster's class. If you use the real code, you can do things that are a lot more complicated than you can with the drag and drop stuff. But everything that we've done so far has been just drag and drop stuff. So what we've been doing is we've been just pulling in, you know, a drag and drop block except I don't really want it, so let me get rid of it. Okay. When you transfer the program to your computer, your computer has to work with the real code, not these drag and drop blocks. So this document that I gave you, I think does a really good job of this, of giving you at least a flavor for how does the real code work. So absolutely positively read through this. And then when you get down to the bottom here, it's pretty much over now, and that's okay. Right. So what I want you guys to do between now and Saturday night is I want you to download the Arduino primer, read the Arduino primer. Don't be surprised if you don't understand everything that that's contained in there. Just read it. And then here's what I want you to do to get credit for this assignment. In fact, let me make it a little bit bigger so it's easier to see. Okay. So download and read the Arduino primer. Then I want, in the text box below, I want you to type in 3 questions that you have that the Arduino primer did not answer. Okay. Because the Arduino primer is not really a very thorough user's guide. It is a superficial, it is an extremely superficial introduction, but that's a good way to start. So I anticipate that after you read the Arduino problem, after you read the Arduino primer, you're going to have a lot of questions, and that's okay. Don't feel bad that you have questions. In fact, I want you to have questions. And so I want you to take 3 questions that the primer did not answer for you, and I want you to type those into the box. Okay. Now, some of you guys have worked with Arduinos before. And so some of you guys are going to say, well, I already know everything there is to know about Arduinos. Nobody knows everything there is to know about Arduinos. I most certainly do not. Even people I know who are really, really good at Arduinos, there's stuff they don't know. So I want you to come up with 3 questions about the Arduino that you would like to know the answer to, and the Arduino primer did not answer them to your satisfaction. That's your homework assignment, and that is what's due Saturday night at midnight. You guys good on that? You understand that? So I want you to type in the chat box. Let me know if you're awake or not. Type yes in the chat box if you understand. Okay, good. Or you can say I'm awake. Okay, that's good. That works too. Okay, good. All right, now that is not your only homework assignment. You also have an assignment that I want you guys to do, and I want you to turn it in next time we meet, or next time we would meet if we were to meet live, which is Monday. So the assignment that I need you to turn in by Monday is this one right here. Small motor powered by an Arduino with a potentiometer-based speed control. Okay, and so here's a picture of it, and let's go into it. Where did it go? What happened to my real one? Did I? Okay, good. Here it is. Okay, so this is my real one. So I want you guys to make this thing in Tinkercad first and get it programmed and get it working in Tinkercad. And then once you have it working in Tinkercad, I want you to download the code. And you guys remember how to download code? If you click on code and then use this icon right here, okay, that'll download the code from Tinkercad onto your computer. And then once you've got it on your computer, then you can upload it to to your real Arduino. Okay, and so then what I want you to do is I want you to take one of these knobs, okay, and notice it's got 3 inputs, and notice the color of the wires that I've used. Okay, so I want you to take the input on the left, and that's the one that you're gonna, you see how the wire is black. Okay, so that tells me that this guy will get connected up to the pin on the Arduino that's labeled GND. This one here is red. Okay, that means that this guy gets connected up to the pin on the Arduino that's going to be 5 volts. And this guy here is some other color. So that means he's going to get hooked up to some other pin. So let's come down here and let's see what they get hooked up to. Okay, so the red wire, let me turn on annotation so I can talk a little bit more easily here. So the red wire connected up to the 5-volt pin. The black wire connected up to the ground pin. And then the yellow pin, you can hook it up to any one of these input pins that you want. I chose to hook it up to pin A0, but you don't have to hook it up to A0. Any one of these pins is good enough. All right. And so that's all you have to do on that. And then as far as the motor, just use the exact same motor hookup that you had before. So that here the motor, I've got them hooked up to pin number 9. And then I've got the black hook up to ground. And then you can see, now I've got my oscilloscope going. Now you guys don't have an oscilloscope. So obviously you're going to leave the oscilloscope out of your real code. But I'd like you to leave the oscilloscope in for your Tinkercad version. Just because what I want you to do is I want you to test it. I want you to see that when you turn the knob, the pulses get skinnier. And then as you turn the knob, they get fatter. And then you come over here, they get fatter still. I want you to be able to see that on Tinkercad. Now, what about the code? You might think that this is really complicated code. Turns out this is actually incredibly easy code. All I need is one drag and drop block. That's it. That's all the code that I need. Okay. So this is it. But let me throw it in the garbage, and let's recreate it from scratch. Okay. So the thing that I want to drag in is this pin, this one right here, that says set pin whatever to some number. Okay. So you realize that I can't use just any old pin. It will only let me use pins 3, 5, 6, 9, 10, and 11. Okay. What is it that's special about those pins? Well, if you look on the Arduino, you'll see that those pins, those are the ones that have the little squiggle next to them. In fact, let me go back into here. Okay. You can see it better right here. Okay. Those pins, those are the ones that have the little squiggle next to them. That means that those are pins where you can use pulse width modulation, which is what we're doing. This whole thing, the way that we're controlling the motor speed is by using a technique called pulse width modulation. And the only pins that are capable of handling pulse width modulation are the pins that have the little squiggles by them. So Tinkercad already knows that. So it will only let us use those. Okay, so for me, I've got my motor plugged into pin 9. You guys can use other pins if you want. It doesn't have to be pin 9, but for me, it's pin 9. So I'm going to set it to pin 9. And then what I can do here is I can type in what number I want it to be. Can anybody remember what is the maximum number that I'm allowed to use? In fact, everybody, again, I need to do a little wake-up check. I want you to type in the chat box, what is the maximum number I can use? What number will correspond to full speed on the motor? Okay, very good. All right, 255 is the right answer. Okay, so if I were to type in 255, that would run the motor at full speed. Anything less will be, some percentage of that. All right. But I don't want to type in a number. I want the Arduino to look at the voltage on the analog input pin and set it based on what it sees there. Okay. So the way that works is if I come down here, so I've decided I'm going to use pin A0. And so the way that it works on the analog input pins is if I were to take a wire directly from my I should make it a red wire. Let me do this again. If I take a red wire and I go directly from my 5-volt pin to my A0 pin, then I will now have 5 volts, which is the maximum that I can put. If I were to ask the Arduino, what number are you seeing on the A0 pin? Okay, it's not going to tell me 5 because it doesn't work that way. It's also not going to tell me 255 because it doesn't work that way either. If I've got 5 volts on here, the number that it tells me it sees is going to be 1027. Now, those of you that don't know binary, you might say, that's a really strange number. Why would it be 1027? Those of you that do know binary are going to say, oh, yeah, that makes sense. Okay. Now, I don't want to take the time right now to explain why 1027 is what they use. I think later we'll talk about it. But so just recognize that if I have 5 volts on here, the Arduino is going to tell me that it sees 1027. And if it's anything less, then it's going to be less. Okay, so now that we understand that, now we can go in and see why the code works. So if I open up the code here, what I want to do is, instead of typing in a number here, so let me turn on annotation again. Every time I make a little adjustment here, I have to turn annotation back off and then back on again. So instead of typing in a number here, what I'm going to do is I'm going to pull in this guy right here. Oops, this guy, sorry, where it says read analog pin. Oops, not, I want read analog pin. Okay. Okay. So now, by the way, what I'm about to do is wrong, but we'll talk about it in a little while right now. So this is what you might be tempted to do. You might say, read analog pin A0, and whatever number you see there, put that number on pin 9. But that's not going to work because this has a maximum of 1027, whereas this can only accept a maximum of 255. So if I try to stick this number into that pin, I'm going to get an error message. It's not going to work. So what I have to do is I have to read this number and then I have to make it smaller. And so this number here is about 1/4 of that number, right? So that's the trick that I need to do, is before I take this guy here, what I have to do is I have to put this in here. So this is a block that allows me to do addition, subtraction, multiplication, division. So I'm going to put this in here. Okay. And then I'm going to take this guy and I'm going to put him in the left. Come on, go in here. Okay, so why are you not working here? Let me try putting it here. Okay, I had it before. Why is it not? Oh, there it goes. Okay. All right. I don't know why it didn't want to go in there. Okay, so what it's going to do is going to read whatever is in analog pin A0, or if you guys prefer to use one of the other pins, that's okay. And then what I want to do is I want to take that number and I want to divide that number by 4. Okay, and then this is what I'm going to stick into there. Come on, cooperate. This drag and drop stuff, in some regards, it's very nice, but in other regards, it's really annoying. Okay, let's see if I can get it to go in now. Those of you that have worked with drag and drop a lot, do you know any tricks for getting this thing to go in there?
Put like the left side of the circle, like more on the left side rather than the middle or the right.
Okay.
the thing that you're translated.
Ah, okay, that worked. Thank you. Nice touch. So you must have done a lot with drag and drop. Okay, so you can see what's going to happen now. So the Arduino is going to, it's going to look at analog pin A0 and it's going to see what it gets. So if I've got the knob turned up all the way to the right, the number that it sees is going to be 1027. It's going to take that number and it's going to divide that by 4. And so the maximum that it's going to get there is going to be some number that's going to be close to 255. Not exactly, but that's okay, close enough. And then it's going to take that number and it's going to set that into pin 9. And so that'll control what the pulse width modulation is. Okay. All right. So now let's make sure that I haven't messed this thing up too badly. Let me clear this out. Okay. So if I haven't messed things up, then what should happen is when I start the simulation. Okay. So now I'm getting nice wide pulses. Now you see the pulses are getting narrower still, and more importantly, if you look at the motor speed, you see that I'm going at about 1,200 RPM. And now when I turn it down here, now I'm only going at about 500 and something. And when I turn it up here, now I'm going like about 3,000. So that is working beautifully. Okay. So now, how do you hook up the potentiometer to the Arduino? Okay. So after you guys get it working in Tinkercad, how do you actually wire it up for real with an Arduino? Well, use the alligator wires. Okay. Clamp the alligator wire on here. Okay. And then get another alligator wire. Actually, I've given you different colors of alligator wires, so it's a good idea to use the same color scheme with the alligator wires. So I'm going to take the red alligator wire and I'm going to plug it up to the one that's on my left. Okay. The yellow one, I'm going to plug it to the one in the middle. And then I had a black one here. Where did my black one go? Here's my black one. And you guys should have all these different colors too. Okay. So the black one now goes to the one on the right. Okay. Be very careful that these guys don't touch each other. If they touch each other, that's going to mess up. You're going to have what's called a short. Okay. And then on the other end of the alligator wire, take one of these little wires that has a pin on it, and then just plug it into the appropriate place in the Arduino. Okay. So these alligator wires are wonderful. You guys are going to love these alligator wires. They come in so handy. Okay, I'm thinking that we've done enough talking. Do you guys understand well enough that you think you could go ahead and do this assignment now? So type in yes if you think that you could do the assignment. Type in no if you think that you would not. Okay, I'm seeing a lot of yeses. All right, remember everything that I just talked about was recorded. And then as later this afternoon, later this evening, I will post this on Canvas. So if you get doing this thing and you run into a problem, you say, oh, I can't remember how to do such and such. Well, it'll be on Canvas. You can watch it there. Okay, so remember you've got an assignment due Saturday at midnight, which is read the Arduino primer and come up with 3 questions. And then you've got the other assignment, which is due on Monday, which is to build a real life Arduino controlled motor where you turn the knob and the motor runs faster. You turn the knob the other way, the motor runs slower. Okay, so you guys can go ahead and type bye in the chat box. And remember, on Monday, I won't be here live, but I will have something for you. So I will see you later. I just don't know when that'll be. Bye, everybody.